right, so we're continuing our final exam review, and we're taking a look. This next one is looking at regression, and this is one of the last topics that we had inside of the course. And so let's take a look at regression. And regression is comparing two quantitative variables, right? So we got two quantitative scales, and they're two different quantitative variables. So not just two quantitative variables from the same population, or from different populations, but two different quantitative variables from the same population for the same individuals. Okay, so let's take a look at something like this, and let's see if we can get a kind of a hang of this. I wanted to know if students scored on the second midterm were statistically correlated with their final exam scores. I collected the second midterm scores and the final exam scores from 105 students chosen at random. Okay, and then used StatCrunch to run my results, and here's the display. So now I look at this and I go, okay, here's my display, and what I want to notice is here's midterm 2. That's my x-axis, what we call my independent variable. Okay, there's my independent variable. And then my dependent variable is the final exam score, right? Okay, and I want to look at this, and if I look at my graph, what I can kind of see is there appears to be kind of like a line that goes right through there. Something like that. Okay, there's definitely a trend. And the trend is that as I increase my midterm 2 scores, my final exam scores go up. Okay, that's definitely what the data says right here, right? Like our highest final exam scores, okay, the ones up there, they also have the highest midterm scores, right? And our lowest midterm 2 scores, they have the lowest final exam scores. So you can kind of see how that kind of works, right? Is it a perfect relationship? No, it's not, but that's okay. We're not looking for perfect. We're just asking ourselves, is there in fact a relationship? All right. So you look, we got our dependent variable final, my independent variable midterm 2. Now, in general, from a mathematical perspective, our independent variable is going to be what we call our explanatory variable, and our response variable is going to be our dependent variable. Okay, that is that if I wanted to go out and predict my final exam score, I would use my midterm score in order to do that, right? I wouldn't use my final exam score to predict my midterm score because the final happens after the midterm, right? Kind of defeats the point of prediction. That doesn't work, right? Can't do that. So we kind of want to be like, oh, okay, that makes sense, right? Now, sometimes we don't have that kind of relationship. Sometimes we have to do some other things, right? Like, say, for example, if I wanted to figure out, like, I don't know, whether or not studying more, okay, improves my test scores. Well, I could actually test and see if my test scores increase the amount of studying that I do. But it will probably make more sense to say, does the amount of studying that I do increase my test scores? Okay, and so my explanatory would be the amount of studying. That's the thing that affects my test scores. All right, so if we think about, like, it's not really cause and effect, but it's kind of like that. My explanatory variable, midterm 2, explains my responses, which is my final exam variable. Okay? And then I got some information here, and this information is actually really handy, really important. This R, correlation coefficient, that's going to tell me how strong. How strong is the correlation, right? Remember? This thing right here, that's the regression equation. This is going to actually be, this is how I am going to do prediction. How am I going to do prediction? It's going to show up later instead of one of our later questions. Then I've got this thing here called R squared. And what R squared is it's called the coefficient of determination. And what it tells me is how much variation is there in the data in the final exam scores that's due to the midterm score. So, like, it kind of also tells me how good a predictor, right, is midterm score for predicting final exam score, okay? And it literally is R squared. So if I took 0.7251161 and I squared it, I would get 0.5279335. And if I took the square root of 0.525799395, right, I'd get 0.7251161. They're related that way, okay? That's exactly how they're related. Okay? All right? They just have different explanations. The strength of my correlation is going to be r, right? And the value of my prediction basically is going to be r squared. Okay. Then I have this information here, and you'll notice this thing here for the slope, right? That's less than 0.001 is my p-value, and that tells me actually that my linear regression equation is at least statistically good to do prediction. Okay? It's at least good enough. All right. So now we actually answered some of these questions already. So my explanatory variable, right, is going to be, now you'd write these in complete sentences, right? Please notice. Explanatory variable will be midterm 2. And my response variable will be the final. Next up, I've got my strength and my correlation. Okay? And so we've done some work with these before. And you'll notice that R is going to tell me my strength and my correlation. It's 0.72511,651. Okay? Now, what I'm going to say is I'm going to say if R, the absolute value of R, that is that if we make it positive, because sometimes it's negative, right, is between, okay, 0 and 0.5, then it's going to be weak. If R is between 0.5, right, so it's greater than 0.5, but less than 0.8, then I'm going to say that it's moderately strong. And if R is greater than 0.8, and then obviously it's going to be less than 1, less than or equal to 1, then this means that the correlation is strong. Notice I look at R here. R is 0.72511,651, so that means that the correlation is moderately strong. So what that means is that there's a pretty good, but not great, relationship between the midterm score and the final exam score. So in general, okay, we could say that the two of them are related, right? The direction of the correlation is positive. And so that means something for us too, right? It's a positive correlation because R is positive, right? It's a positive correlation because that line that I just drew has a positive slope, right? It's going upward, right? As midterm 1, 2 goes up, the final exam score goes up as well, okay? So positive because, okay, it's positive. And let's get with a little interpretation here. That means as midterm 2 increases, the final exam score increases. So I, as a teacher, would want to know, well, let's take a look at your midterm score, right? Okay, let's say your midterm score is like 73. I might ask myself, well, you know what? What does that say, right? And then I have another student, and they've got a midterm score of 90. And I ask myself, based upon my data, based upon my information, what do I think in terms of their relative final exam scores? Well, the second student who got the 90 on the midterm, I'm going to say they're more likely to actually get a higher final exam score based upon my information. As we increase the midterm score, right, we increase the final exam score. That's kind of how that works. Increase the midterm score, increase the final exam score. Okay? There we go. Now, according to the t-test is their correlation. Well, we saw that the slope, right, when we looked at these parameter estimates, the slope here was had a p-value of less than 0.0001. What that means is that the slope is not equal to 0. Now, saying that the slope is not equal to 0 is actually telling me that there is in fact statistical evidence for a correlation. Okay? So, since in the test for slope, P was less than 0.0001, okay, so it was actually very small, the slope does not equal 0, right? So it's not flat. And since the slope is not equal to 0, this tells me that there is a statistical correlation. So I'm looking at this. I go in, I've got a bunch of indicators that there actually is a linear relationship. One, I can pretty much see it in the data, right? That line, definitely positive slope, right? As the midterm increases, the final exam increases. All awesome. Okay, everything like that looks good. It's solid. Then I look down here, my correlation coefficient is moderately strong. It's pretty strong. You know what? That's also a good indication that I'm going to have a relationship between the two variables. Then finally, my slope, when I look at this p-value, that p-value is going to be less than 0.001. So that tells me, in fact, that it's statistically significant, right? That, in fact, there is a correlation there. Remember, what I want you to remind you is that it's that slope value that tells me that the correlation is there, okay? And so I state that. There it is, okay? And then finally, yes, there is a statistical correlation. Then finally, how much variation in the final exam score is due to a student's midterm exam score? Well, that's the question that this one here, R squared, represents. Since R squared is 0.5258, the amount of variation due to midterm score is 52.58%, which is awesome. Okay, it's actually pretty high. It's pretty high R squared. Okay, what this tells me is that 52.58% of a student's final exam grade can be predicted just by knowing their midterm exam score. Okay, and how do we find that? It's R squared. That's called the coefficient of determination. Okay. Now, finally, on this, one of the things we want to know is how do we use this now for prediction? All right. Now, I look here. The linear regression equation that relates midterm 2 grades to the final exam grades is this one right here. Okay. It corresponds, you'll notice 35.507 plus 0.542x. It corresponds to this thing right here. Final equals 35.507 plus 0.541 times the midterm. Okay. X, that's my dependent variable, and y, x is my independent variable, and y is my dependent variable. So this one here, that's final score. And this is the midterm. So if I want to predict the final exam score, how I'm going to do that is by plugging in the midterm score. Okay? So, what would be the predicted final exam score for a person who gets 75 on a midterm 2? Well, what I'm going to do is my final exam score, y hat, is going to equal 35.507 plus 0.542 times 75. And I'm going to use that in order to solve. Okay? So, I'll first take 0.542 times 75, okay, plus 35.507. Okay? And that will give me 76.157. Couple things to notice. This is actually, and I do kind of know why. It doesn't really matter why. What you want to notice is that this is like m. This is your slope, 0.542. Then we have x, and this is called the intercept of the y-intercept. So it's actually b plus mx, right? Y hat is b plus mx. And if you remember from your algebra, that's a linear equation. Normally we'd write it as, or in algebra you write it as mx plus b. In statistics, we put the intercept first, right? And then we add the slope times our independent variable. Okay? So we use this regression equation is what we use for prediction. It's telling me that if an individual got a 75 on midterm 2, then I expect that they're going to get 76.157 on midterm, on their final exam. Okay? And that completes what you need to know in terms of, well, a good chunk of what you need to know for regression, right? Regression connects or tries to figure out what the relationship is between two quantitative variables coming from the same population. Okay? And we use it in order to figure out, in order to do prediction. Okay? So that completes this particular review video.